Hey guys, so I just wanted to make a short video because a lot of you said that you were struggling with the amino acid ionization and when the different groups will be ionized at different pHs. And I just wanted to do a short video just to kind of hopefully summarize that. And I'll give you, first of all, just the take-home message, and then I'll give a short explanation about the kind of why that will help you hopefully understand why and why this is important shortly after. Now, if we start out with an amino acid, like I have here, and this amino acid wouldn't actually exist in real life because one or both of the groups would be ionized. So the carboxylic acid here or the amine group here, one of them or both of them would be ionized. But here, neither of them are. So this one wouldn't actually exist, but we'll just stick with it for now. And we always draw the amine group to the left and the carboxylic acid group to the right. And we know already that each of these groups have got a pKa. And the carboxylic acid, it depends on the amino acid, but the pKa is usually about 2.2. And for, it could be 2.1, 2.2, 2.3, but it's about 2.2. And for the amine group, it's usually about, let's say about 9.5, a little bit more variation here from about 9.2 to about 10.5, but 9.5 covers about the average. And I don't really expect you guys to even memorize that. The really take-home message really is that 2.2 is pretty low. Again, pKa is on a scale from 1 to 14, just like pH. And so 2.2 is right near the bottom, and 9.5 is kind of near the top. I mean, it's over neutral. It's 7, so it's over that. It's certainly more on the basic side of things. Now, how is this important? So the general rule is if the pKa, or let's go actually the other way around. Ooh, this is my F. If pH is less than pKa, then has gained H plus. Okay, so, and let's give that a red thing. Okay, so this is a rule to stick with. And so that would mean that if it's gained, then you're going to have CO2H, not CO2 minus. And so I guess it hasn't really gained, but it just kind of has. Really, it could just kind of cross out the gained, really. Has H plus. So in this case, it would have the H plus here, or for the amine group, it would be NH3 plus if the pH is less than pKa. Now let's show that on a table. So if we have the two groups, and I'll start out with the CO2H and the NH2, and we'll look at them at three different. Oh, that looks kind of like a 3. Let's fix that. No, come on, Ben. Oh, man. Oh. Testing out this new fancy pen, and there we go. It's okay. Okay, so let's start out. I'm just going to pick 3 pHs, and I'm just going to pick a pH that's very low, a neutral pH, and a pH that's very high. I'm purely picking them just because they are, they could be anything around that range, but I'm just going to give you guys something very low, something very high, and something in the middle. So we'll go with pH 1, that's very low, pH 7, which is in the middle, and pH 12, which is at the top. Now, so this is the golden rule. This is all you got to remember is this table. At pH 1, let's do we'll draw our 2.2 and our 9.5, the pKa. to even remind you, but it's up here. So is 2. So at pH 1, is 1 less than 2.2? Yes. If 1 is less than 2.2, yes, then has H plus. So this has its H plus, so it's CO2H. Not CO2H2, okay? Because it can't gain another proton, but it's just going to be as protonated as it can be. Whereas now for this one, is 9.5 greater than 1? Yes. If pH 1 is less than 9.5, it is, then has the H plus. So it'll be NH, and it's gained 1, 3, because it can gain 1. Now we'll move on to the next one, pH 7. Now is if pH is less than pKa, is 7 less than 2.2? Nope, which means that it has not gained H plus, so it's going to be CO2 minus. So it will not gain. See, this is why I crossed out the gains. It has, so it does not have. So it will be CO2 minus. Likewise here is 9.5, 9.5 and 7. If pH is less than pKa, is 7 less than 9.5? Yes. That means that it has H plus, so it'll be NH3 plus. Final one, pH 12, pKa 2.2. If pH is less than pKa, if 12 is less than 2.2, it is not. So it is not. So thumbs down. Then it does. So it doesn't gain H plus. So it will be CO2 minus. And is 12 less than 9.5? Actually, no. This time 12 is greater than 9.5. So it will not gain H plus. So it'll be NH2. So the main thing is that at a low pH, the carboxylic acid group will not be ionized because the pH is less than pKa. Not the same for this one. And at pH 12, this one will not be able to gain a proton because 12 is greater than 9.5. And then at pH 7, they both are. So that's all you have to remember. At pH 1, the amine, pH 1, the amine is, and the carboxylic acid isn't. At pH 7, they both are. And at pH 12, the carboxylic acid is, but the amine group would not be. That's just what you've got to remember. And the reason why is because this is pKa is reflecting acidity. And if the pKa is less than 7, then it's saying that something is acidic. And as well as acidic, and the more under 7, the more acidic. And if the pKa is greater than 7, then it's saying that it's actually flips the other way around and it's basic. And the more it is over 7, the more basic it is. And so this is reflecting really how much it wants to give away its proton. And so at a neutral pKa 7, doesn't really want to give away its proton very much. Whereas if you bring the pKa down and down and down, it's saying that it wants to give away its proton more and more and more. And on the other hand, for the base, if as you get the pKa increases, it says that it wants to take up a proton more and more and more. And remember, when pH is equal to pKa, then you have a 50-50 split of the ionized and non-ionized. And so if you therefore have something that's acidic, and let's say it's about not very acidic, so about pKa 6, then that means that at pH 6, then it's going to be at that 50-50 of whether or not it's given away its proton or not. But then if you get to lower than pH 6, then that means that there is an even stronger acid, which is preventing this weak acid from being able to give away its proton. It's kind of bullying it and preventing it from giving away its proton, because this is a weak, not only is this a weak acid, it's a very weak acid because of the pKa is only 6. Whereas if the pKa was, say, 1, they're still classified as a weak acid, but it's a stronger weak acid. And so the pH needs to go down lower before you can force it to be at that 50-50, where it's no longer kind of in a position to give away its proton so much. And so it needs an even strong acid to bully it and prevent it from giving away its proton. And it works the other way with the bases. And because of course pH, as you go down in pH, that's reflecting that there's more protons. If there's more protons, then there's less room for the weak acid to be able to give away its proton, unless it's a stronger one of the weak acid saying, oh, well, I don't care that there's tons of protons. I want to give it away so bad that I'm still going to give away my proton. So at pKa 6, doesn't really want to give its proton away very much. So by the time you get down to pH 5, it's acidic and there's a bunch of protons around, but it's not even that many. It's still not that far from neutral. And so it doesn't take a lot to be able to bully this and prevent it from giving away its proton. On the other hand, if you went, as you go down and down and down in pKa, it's getting more acidic, and so it can kind of, more protons are required by a stronger acid in order to prevent it from ionize. And sorry to go back, with the base, it's the other way around. As you go up in pH, there are fewer protons. And so if you had something that was, say, pKa 9, that's an awful K, then that's saying that, or let's go for 8. That's only kind of weakly basic. It's not a lot over neutral 7. And so that's saying that it doesn't really have much of a tendency and desire to pick up protons. And so as you go up in pH, you're reflecting that there's fewer protons around. And so this doesn't want them that much at pKa 8. And so it doesn't take a lot of removing until it's kind of gives up. Whereas if it was pKa 11, that would say that it will continue to take up protons and be ionized right up till you get to about, did I say 11? Right up till you get to about pKa 11, when it will suddenly be like, oh, it'll be 50-50 because there's just not enough for it to want to take up. And so as you go up to 12 and 13, there's not enough, and it'll be majority unionized instead. But if you went up in pKa, then there would have to be even fewer protons before it gets that 50-50, because it just wants them so badly. So an acidic pKa is reflecting how much it wants to give away protons, and the lower that pKa, the more protons that are going to have to be present, i.e. a lower pH, before it kind of forces it to no longer give away its proton. And the other way around with the bases, a pKa over 7 is reflecting that it's basic, and it's saying how much it wants to take up a proton. And the more the higher the pKa, the more it wants to take up a proton, and the more it will take one with there being fewer around, i.e. a higher pH. And how competitive. I guess competency is another way to describe it. A lower pKa means it's more competitive to give away its proton, and a higher pKa is reflecting it's more competitive to want to take one up. And whether or not the existing pH by another base or another acid being present is whether or not how much it's competing for that. So I hope that makes it kind of clear. But really, the take home, just remember this. Just remember this table. pKa is about 2.2 for the carboxylic acid, about 9.5 for the base. I'll give you guys a very obvious, very acidic pH 1, very basic pH 12, And just know that under very acidic conditions, the carboxylic acid will be unionized and the base will be ionized, because there's too many protons for this to be ionized, and that too many protons is grand for the base. At pH 7, there's a nice balance, so they will both be ionized. Not too many protons, so the acid can give it sort of one away, and but there's still a good number of protons, so the base can take one up. At pH 12, there are so few protons. Well, the acid doesn't care because it wants to give them away. There's no competition; it can just give them away. But the base is being outcompeted for protons by something else, and so it cannot be. There's no protons to take up, so it won't be ionized. So just remember this bit here, and I hope this this helps. And please contact me. Come by and we can chat if you want me to go over this a little bit clearer. But hopefully this makes sense to you now. Thanks very much, guys.